Hi, I'm Max Mao, data engineer from Google Cloud Cortex framework. Today, I'm going to walk you through the configuration of Directed Acyclic Graphs, or DAGs for short. As a recap, Cortex framework generates DAGs. These are scripts used by Apache Airflow or Cloud Composer, which will orchestrate and schedule the operations in them. These operations will execute the merge statement of new records or the periodic ingestion of data from an API, among others. As a reminder, thanks to the principle of openness, the scripts are generally separated from the composer-specific configuration. This way, you can use another tool to schedule them if you prefer. If you are generating DAGs for data ingestion or for change data capture processing, you will find some YAML files to configure along the way. I will use the SAP files as an example, but you will find this pattern in all workloads. This file indicates to the script what sources to process and how frequently. In this case, the script will go through this file to capture details. Examples include execution frequency and performance improvement settings, such as the partitions and clusters for the target table. And it creates a DAG for Cloud Composer based on this template and the fields from the source tables from SAP. Because some replication tools replicate data in near real time, you also have the option to use a view that searches for the latest updated record instead of a schedule script that updates a materialized table. For Salesforce, by default, these DAGs will generate the calls to ingest records from the APIs with a very similar template. In both cases, you can add additional source tables or different APIs to this file, as long as the metadata is available in the same way as for the delivered templates. The DAG generator will then pick them up and create the artifacts for them. For marketing, it is a very good idea to check the documentation to understand the requirements for each data source you may want to implement. This applies to all workloads, as we will be adding more in the future. Let me make an important note about clusters and partitions here. For large volumes of data, we recommend applying partitions to the replicated data in the raw dataset and to the CDC dataset. Partitions are useful when you want to limit the scan surface of a table. For example, when you are applying CDC to newly ingested records and want to update all records after a given timestamp. To reduce the number of partitions and metadata access time, it is a good idea to create the partitions based on data freshness requirements. You may also have to configure partitions in the replication tool for the raw dataset in cases like with SAP. Clusters will further reduce the scanning surface and are more relevant in reporting queries, where the filters and aggregations include multiple columns. You will also find that, in cases where you have more than a specific number of years worth of data, you do not need to have all of them available for reporting. It may be a good idea to split the larger tables and only tap the oldest part when it makes sense. These types of tweaks will improve performance and lower costs, but are specific to how the data is used in each company. It is also a good idea to monitor usage and consumption as the business needs evolve, and look at tools like the BigQuery recommender to make adjustments. You will find more information about partitions and clusters in the documentation and links in the description. Last but not least, if you make changes to your DAG because something is slightly different, we recommend submitting the generated templates and their changes into version control, so the upgrade process is easier with future versions of Cortex. Please check the description of this video for more information. See you!